Let us continue with Chapter 2. In this video, we will discuss uniformly accelerated motion. We will apply equation of motion with a uniform acceleration, and we will apply equation of motion for free fall. For uniformly accelerated motion, we have these three important equations, which are V equal to U plus AT, S equal to UT plus half AT squared, V squared equal to U squared plus 2AS. You did not need to remember this equation because it will be given in your exam. But what we need to know is the terms for each of the symbol. V here represents the final velocity, U represents the initial velocity, A is uniform or constant acceleration, T is the time, and S is the displacement. Before we substitute the value into the equation, we need to consider the sign convention. For S, positive S means that the object moves to the right and negative S means that the object moves to the left. Same thing as the velocity. Positive means that the object moves to the right and negative means that the object moves to the left. But for acceleration, positive means that the object is accelerate and negative means that the object is decelerate. There are special cases, for example, uniform velocity. As we know, when the velocity is constant, the acceleration is equal to 0. Therefore, the value of u is equal to v. So our equation will become S equal to ut. There are a few situations where can we apply this equation. For example, a racing car is running on track. As we can see, the image are equally spaced, indicates that the object is moving with constant speed. Therefore, the acceleration is equal to 0. Another situation is a cyclist starting a race. An increasing distance between the image shows that the object is speeding up. Therefore, there will be change in velocity. The initial velocity u is equal to 0 since it states here that the cyclist is starting a race. Next, we have a car stopping at a red light. So decreasing distance between the image shows that the object is slowing down. Therefore, the value of acceleration will become negative value since it's decelerating. And the car stopped at red light. Therefore, the final velocity is equal to 0. Another example is a car slowing down for a red light and a car is speeding up after a green signal. Let's do this example. A plane lands on a runway at velocity 50 meters per second and decelerates at constant rate. The plane travels 1 kilometer before stops. Calculate the deceleration of the plane, the time taken for the plane to stop. Remember that before we use the equation or before we choose the suitable equation, we need to list down all the information given in the question. So you are given the initial velocity of the plane, which is 50 meters per second. And we know that the plane stops. Therefore, the final velocity v is equal to 0. And the displacement is 1 kilometer. So we need to change first to SI unit. So it will become 1000 meter. And for question A, you are asked to find the deceleration of the plane. So, how to choose the correct equation? So, we have V, we have U, we have S, and we need to find A. Remember that three equation. So, the suitable equation is V squared equal to U squared plus 2AS. And substitute the value into the equation, and we got A equal to negative 1.25 meter per second squared. What's mean by negative sign here? Negative sign here means that the plane is decelerating. And for the next question, by using the equation of linear motion, we know that V equal to U plus AT. So we already have the value for U and A. So we will get the time taken for the plane to stop, which is 40 seconds. Or we can use S equal to UT plus half AT squared. We know S equal to 1000 meter, and we will got the same answer. Next, we will focus on equation of motion for freefall. So for freefall, we also have three important equations. You do not need to remember this equation because it will be given in the exam. So we have V equal to U minus GT, S equal to UT minus half GT squared, V squared equal to U squared minus 2GS. And before we apply this equation, we need to know the meaning of the symbols there. So V here represents the final velocity, U is the initial velocity, G is the value of gravitational acceleration or acceleration due to gravity, which is 9.81 meter per second squared. T is the time interval, and S is the vertical displacement. What is free-falling body? Before this, we focus on linear motion. Can you differentiate between linear motion and free-falling body? Yes, linear motion involves x-axis, which is to the right or to the left. But for free fall, it involves upwards or downwards. Okay, so free fall motion is the vertical motion of a body at constant acceleration g under the influence of gravitational field without air resistance. So the keywords here for free falling body is without air resistance. So from free falling body, the object is thrown downward or upward at angle 90 degree, or the object is thrown at y-axis. So in the Earth's gravitational field, the value of acceleration is 9.81 meter per second squared, also known as acceleration due to gravity or free fall acceleration. Negative sign here indicates that the direction of gravitational acceleration always towards the center of the Earth or downward. And the value of g is always constant, which is 9.81 meter per second squared. Note that in solving any problem involving free-falling body or free-falling motion, we always assume that the air resistance is ignored. There are a few situations for free fall motion. Note that when we solve the problem regarding the free fall, we need to consider the direction. For example, we have an apple is dropped downward. So when apple is dropped, the initial velocity is 0. U is equal to 0. And this here is the initial level. And time here is 0. Okay, when the apple goes down, what happened? The displacement will increase but the sign is negative. Why? Because it is below initial level. The velocity of the apple also increased, but in negative value. Why? Because the apple moving downward and the value of t increasing. Note that the time is scalar quantity, so the time will always be positive. And when the apple hits the ground, the displacement will become maximum and negative value because it was dropped below initial level. And also the value of velocity will be maximum and negative because it was thrown below initial level. The next situation, we have an apple thrown downward, but u not equal to 0. So what happened? U thrown downward, so the value of u should put negative sign because the direction of the apple is downward. Okay, and when the apple goes down, what happened? The displacement will become increase and negative value because it below initial level. What about the velocity? Velocity also increase but in negative sign because the apple move downward and the time will increase. At the end, when the apple hits the ground, the value of displacement is maximum and negative because it's below initial level, and the value for velocity also maximum but negative value because it moved downward, and t here will be maximum. Next, let's take a look at the third situation. The apple is thrown upwards at u not equal 0 meter per second from the ground. So here, our initial level is at the ground. So at initial level, our displacement is 0 and u is positive value. Why? Because we thrown upward and t is equal to 0. So when we thrown upward, what happened? The value of displacement will increase and positive value because it is above initial level. But the value for velocity, the magnitude for velocity will decrease. And v still positive value because it moved upwards. And at some time, it will be at the top, at the maximum height. So what happened at the maximum height? The displacement here is maximum and positive. Why? Because it is above initial level. But here v equal to 0 because at maximum height, the apple will stop and move downward. As the apple move downward, the value of S will decreasing. The magnitude of S will decreasing, but it will be positive value because why? It is still above initial level. And for V, the velocity will be negative and the value, the magnitude for velocity will increase. And as the apple hits the ground, the displacement will become 0. Why? Because it is at the same level with the initial apple. And the value of v is negative but maximum because it moved downward. And here, t we call as the flight time. And t here is maximum. For case 4, an apple is thrown upward at u not equal to 0 meter per second from a certain high ground. Therefore, at the initial point here, our s is equal to 0. U is positive value because we thrown it upwards. As we turn it upward, the displacement S will increase, and the value is positive because it is above initial level, and the value of V decreasing but still positive value because it moved upwards. And when it reached the top in maximum height, the displacement is maximum positive because it is above initial level, and here V equal to 0. So what happened? The apple will move downward. So when the apple move downward, the displacement decreasing but still positive value. Why? Because it is still above initial point. But here, what happened? The displacement is 0 because it is at the same level with the initial displacement. And our V here will become negative because it moved downward, but the value of V will increasing. As the apple move down to the ground, the displacement will become negative and increasing because it is below initial level, and our V also become increasing and negative because V move downward. Here, our time is maximum and it is called as the flight times. So, as the conclusion, to solve linear motion and free-falling motion, we need to consider the sign convention. So, for x-axis, we have positive to the right, negative to the left. And for y-axis, free-fall motion, we have positive upwards and negative downward. So here is the table to differentiate between linear motion and free-falling motion. So for linear motion, our A depend on the object, depend on the acceleration. But for free-falling body, our A is equal to gravitational acceleration, which is 9.81 meter per second squared. Let's solve this problem. A book is dropped 150 meters from the ground. So here you are given the displacement from the ground. But remember that the book is dropped. So here is the initial level. So from here to ground means that the book will move downward below initial level. Therefore, for your displacement, we should put negative sign. Determine the time taken for the book reach the ground. Here, the book is dropped. So, means that the initial velocity is 0. So, we have S, we have U, we need to find the time taken. The suitable equation is S equal to UT minus half GT squared. And since it is free-falling motion, we can use G equal to 9.81 meter per second squared. So, we will get T equal to 5.53 second. For the second question, determine the velocity of the book when it reached the ground. So, we can either use equation V equal to U minus GT or V squared equal to U squared minus 2GS. Note that we know that U equal to 0 and S equal to negative 150 meter. Negative here because the book move below initial level. Therefore, we substitute the value into the formula and we get V equal to 54.2 meter per second. Note here that we get V is negative sign. Negative signs means that the velocity is downward since the book move downward. So, test your understanding. You can check your answer with this question. That's all for Chapter 2. We will continue with Chapter 3 in the next lesson. Thank you for listening.